Okay, so the first steps is obviously marking the blades up on the flat bar. Now this is 9260 flat bar spring steel, which I get from a suspension factory, which is in the capital city of my state. They make suspension leaf spring systems for truck beds and full drives and custom setups like that. So they have spring steel in stock, which they shape and they heat treat on site. I do my own heat treatment, but they were an option in my very early days for heat treatment. Now this sword is actually going to be more of a rapier blade. It's quite a narrow blade, and so for this one I've chosen 8mm stock. It's quite a heavy stock. For the slightly broader blade, I'm going to be using 6mm stock. It's going to be quite unusual. The fuller on this one is going to be a lightning bolt shape, and there's going to be a weird sort of rivery, watery stream type shape ground into this one as a shallow fuller, which is going to cradle the twin fullers, which are going to start there. So it's going to be some really unusual stuff. But because I put a few marks in there which are not my final scribe lines, I've used enamel paint and I've filled those marks in. Now I've obviously center punched where I'm going to be drilling, and for the round shoulder transition I'm going to be drilling 2 holes. Now I've also planned some of my cuts ahead of time. So I'm going to be drilling holes here and here, which when I cut this out, the profile I'll be cutting out with the cut-off disc on an angle grinder. I can cut from that hole to that hole. These two swords are linked, so they both have a hand ground fuller and twin fullers. This one's going to have short twin fullers here. The main things I want to say about drilling high carbon steel is you don't want to stop. You don't want to give it time to heat up. You want to use sharp bits and you want to make sure you push right through. Don't stuff around. If you stop, you'll heat up the steel and it'll instantly get a hardened skin, and it makes it very hard to drill. You need to use a coolant. You can just use a spray bottle, like a trigger spray thing. Now what you can use if you go to the hardware store or a gardening nursery is you can get some white oil for pests, which is just a soluble oil. And you can put that in your trigger sprayer and your drill press at home and just keep wetting it down with the lubricated water. Makes a good coolant. Now I do drill before I do my fullers. The reason for that being is running your fullers, which normally I run my fullers up the tang, which means it goes right past where I want to drill that. And while I'm running the fullers, I can impart some heat onto the sword blade, and even that can toughen it up and make it a real pig to drill. I'm going to use the depth of the fuller and the tang as a guide for the hand carved fuller that I'm going to put on there, but I also like to fuller tangs just to save weight. If you look at most historic swords, the tangs are fullered. They usually stop around mid-hand level. Not many people have really considered why they stop at mid-hand level. I think it's because the sword pivots on your middle 2 fingers in your hand. If you imagine anything forward of those fingers is adding blade bias, weight bias, whereas anything behind it is adding counterweight. So by stopping the fuller at mid-hand, you're allowing more counterweight behind your hand and taking away blade bias in front of your hand while reducing overall weight. That's my opinion anyway. This is a little gauge I made for fullers. So I've actually done various sizes. So you can see that's a 1/2 inch bit, that's a 5/8 bit, that's 11/16 bit, and that's a 3/4 inch bit. Yeah, depending what I'm doing, this tells me how wide my fuller is going to end up. So depending how wide the fuller is I want, I know which size bit to use. So it's a nifty little gauge. And then on the other side, I've just run the belt sander over it. So I'm doing the same thing, but just showing for contact wheels, a 1-inch contact wheel, a 1.5 inch, and a 2-inch contact wheel, and a 3-inch contact wheel, and a 6-inch contact wheel, just to show me how wide the fullers end up. You can actually cut them to leave only about 1.5 millimeters of webbing between the fullers, and that's historic. I've had a chat with Peter Johnson about that, and he's documented them with webbing between the fullers around 1 millimeter thick. So when you're making a Viking sword blade, they're obviously fairly thin, and taking out those fullers can get you a more historic and realistic handling Viking sword blade. For a lot of medieval sword blades, I'm starting with 6mm stock. I'll take 2mm fullers out and have a 2mm webbing between them. So somewhere between 1 and a bit and 2mm is a good webbing thickness between your fullers. And some time later, the fullers finished machining.
Got my audio book. Let's go.
Now we've got the blade blanks cut out, and I was just going to give you a little look at the sort of accuracy that I can get with the cut-off disc on the belt angle grinder there. So yeah, it's around 1mm to 1.5 mm away from the edge, which is fine. I'm going to go and refine that now on the belt grinder.
You notice I wear a bit of motocross gear. I've got my motocross goggles, I've got my kidney belt, the back support. Doing that angle grinding, it just reminded me how much it kills my back doing that hunched over sort of work.
I've finished profiling the blade blanks now. Most of it done with the vertical platen, the rounded sections done with contact wheels, and then the straight section here was just refined with file. File's always going to give you the nice perfect flat straight edge and very fine control.